We're back with more consonant manner, and we've already talked about the approximants, that is the liquids and the glides, and now we're going to go through the rest of the consonant manner classes. So this is starting on page 4 of the handout, section 3.2, with nasal consonants. So in a nasal, or more correctly, a nasal stop, air flows through the nose rather than the mouth. That's sort of straightforward enough. How does this work? Well, what did I do with my piece of chalk? You're generating all the sounds that you generate, for the most part, from your lungs and pushing air up into your vocal tract through the glottis. In a nasal, you keep your velum here hanging down so that there's this open port here, and air flows through the nasal cavity and through the oral cavity, except in these sounds, the oral cavity is stopped, and so it only really flows through the nasal cavity for the most part. If you instead take your velum and you raise it up, you're going to close off this port, and the result will be airflow only through the oral cavity. That's an oral sound, or a non-nasal sound. The nasal consonants or nasal stops are sort of interesting because they have this dual nature. What do I mean by that? Well, they're going to be loud, like approximants, because they have a relatively open nasal cavity that air is flowing through, so they're sort of like wide sounds in that regard, and in acoustic terms, they have a lot of sonorous energy, like a glide or a liquid. But in articulatory terms, it's a little bit different because somewhere in the oral cavity, there's going to be a complete closure here. Right? So they're sort of a little bit like stops, but also a little bit like approximants. These may be called nasal stops as opposed to oral stops. And in general, in English, they're virtually always going to be voiced. In other language families, it's possible to have voiced and voiceless nasal sounds, but most of the languages we'll look at this semester only feature voiced nasals. Right? So in English, we have 3 contrastive nasal sounds: the labial nasal m, the alveolar nasal n, or coronal nasal n, and the velar nasal or dorsal nasal, which is very hard to distinguish for English speakers at the beginning of a word. It's nga, and because this is easier for most speakers to hear following a vowel, we tend to refer to it as eng, or engma is the name that we use for that velar nasal, and so it can be very hard to distinguish from n for speakers of many languages. And in most of the languages spoken in this classroom, if you have an engma, it's probably not contrastive with the coronal one at the beginning of a word, but it probably is at the end of a word or end of a syllable. Nasals in English and many other languages can take on other places of articulation when they come before other consonants. These are not sort of contrastive phonological features in most of these languages, but it's really just a nasal that takes on the place of articulation of a sound that follows it. It's called assimilation or co-articulation. This is very common cross-linguistically. So in an English word like tenth, where that final sound is dental or interdental, th, generally speaking, the nasal that comes before it will also be partly or wholly a dental nasal, tenth. Before the labiodental f, generally that nasal before it is going to also be labiodental, symphony. That M with the little tail here is going to be a labiodental nasal. This is almost never important in any language. You won't see the symbol a lot. What else do we have? Okay, those were the 2 examples where the nasals take on places of articulation that are sort of not canonical English sounds, but it's because they're stealing their place of articulation through co-articulation with a following sound. Many other languages have nasals at other places of articulation. And so, for instance, the retroflex nasal na, that would be active in many languages of Australia and the Indian subcontinent. Palatal nya also active in many different languages. For instance, the delicious Italian potato pasta, gnocchi. Those are begin with a palatal nasal. Spanish also has this palatal nasal. I think in Spanish it only occurs in word medial position, although I could be wrong about that. But here's a minimal pair, and so the word peña with a medial palatal nasal means something like crag or rock, but pena with a dental or a coronal nasal means trouble. So peña, pena. Pretty easy to hear. It's pretty common for different languages to have only one place of articulation for nasals at the ends of words. This is a pretty common pattern cross-linguistically that, like Spanish, you'll have a whole bunch of nasals when you're before a vowel, but at the ends of words, there's only one nasal. And so this type of nasal, in some languages, has a weak or non-existent oral closure over here in the vocal tract, and it may be referred to as a nasal glide. In general, this kind of nasal sounds very similar to a velar one, to engma, and you'll often see phonologists writing it that way because it's very hard to tell by just listening whether something is a velar nasal or a placeless nasal glide. So for instance, you'll see things written this way in Mexican Spanish and some other varieties of New World Spanish. The final nasal in a word sort of sounds velar, and it might be velar. In Japanese, you'll see the same thing. Frequently, the final nasal in a syllable or in a word will be written as a velar nasal. In Japanese, we're actually more certain that it is not a velar nasal. It's basically a nasal glide with no obvious constriction anywhere in the vocal tract, really. But this is a common pattern. Now, in I think more standard varieties and certainly European varieties of Spanish, in general, you get the same phonological pattern, right? You can have ma, na, nya in different words before vowels. But at the end of the word, you only get one place of articulation in just about all varieties of Spanish. In European Spanish, this tends to be the alveolar, or excuse me, the coronal nasal na, right? In other varieties of Spanish, it can be a velar one or possibly a placeless nasal glide. But that's a useful thing to know about Spanish because there's so many Spanish speakers in here. Okay, so we got through the approximants. Now we've gotten through the nasals. The nasals and the approximants together are referred to as sonorous consonants, and that's because they have this kind of loud vowel-like quality that comes from letting significant airflow through somewhere in the vocal tract without much of a constriction. The complement of sounds, as I mentioned earlier, are referred to as obstruents, and these are ones with a significant constriction somewhere in the oral cavity that stops or almost stops airflow through the entire vocal tract. Nasals don't quite count because they allow airflow through the nasal cavity. You close that velum, you separate these two cavities, and now you're basically stopping all the airflow through the entire system. And when you create a very narrow constriction like that, it's going to result in noise. Sounds with noise are referred to as obstruents. So again, going down the scale from least consonantal to most consonantal, we can start with fricatives here. And fricatives are sounds produced with a constriction narrow enough to cause turbulent, chaotic, noisy airflow. Right? But that doesn't completely stop the vocal tract or airflow through the vocal tract. In general, when you produce a very narrow constriction, it's going to result in acoustic noise, and this is an aperiodic sound with energy spread evenly across a range of frequencies. Maybe not all frequencies, but a range of frequencies. We'll see what this looks like when we talk about acoustics next week. What a fricative ends up sounding like depends on how fast the airstream is or how fast the pressure fluctuation is, as well as the location of that constriction in the mouth. And fricatives occur at virtually every place of articulation. So English is pretty rich in fricatives. We have voiceless and voiced fricatives at the labiodental, interdental, alveolar, and postalveolar places of articulation. Those pairs would be voiceless f, th, s, and sh. and voiced v, the, z, and zh. There's one last fricative in English, which is the glottal fricative, and that's a voiceless fricative. It's going to be almost impossible to produce voicing and a glottal fricative at the same time. See if you can think about why. But so yeah, we have this voiceless glottal fricative ha in English as well. The distinction between the post-alveolar fricatives, sh and zh, versus their alveolar counterparts, s and z, is sort of stated as a difference in minor place of articulation, that they're alveolar versus post-alveolar, or anterior, s and z, versus non-anterior, sh and zh. But it's not totally a difference in the place of the articulation. It's really just as much in tongue shape. And this got separated on pages 4 and 5, but there are some drawings on page 5. These are sketches. I don't think they're made from real X-ray tracings of what a typical or canonical s, z, and sh, zh pair might look like, with the tongue, with the front part of the tongue, the tip, and the blade. And as you can see here, there's this sort of dome shape for the post-alveolar consonants, sh and zh on the right here, where you've really sort of pulled up the blade and the area behind the tongue tip to approximate this entire stretch of tissue extending backwards behind the alveolar ridge. And so, yeah, if you compare that to the shape on the left, which is the anterior s and z pair, it's true that the constriction is further forward for the ones on the left. But really that constriction for the post-alveolar ones is sort of present all the way from the teeth back to the palate. It's just a very long constriction, and it's really the raising of the area behind the tongue tip that's the main difference between the two of these. There also tends to be, interestingly, lip rounding for the post-alveolar ones in American English. I'm not sure about other languages, but you'll frequently find sh with rounded lips. There's a good acoustic reason for that, which we won't get into here. Ask me later if you're interested. You'll see the place of articulation of these post-alveolar ones in particular, sh and zh, described in a lot of different ways depending on what you're reading. They can be called post-alveolar, alveopalatal, palatoalveolar. Some people might even call them palatal, although that's probably not quite right. And as you can see in these diagrams, the constriction really extends through the entire alveolar and through part of the palatal region. So all of those labels are kind of correct in a sense. I'll usually refer to them, I think, as post-alveolar, but I might let one of these other terms slip once in a while. These four special fricatives, s, z, sh, and zh, are referred to as sibilant fricatives. What does that mean? Well, phonetically, it means that they're noisier and have higher frequency noise than other fricatives. The reason why is because the tongue tip here is going to be creating a very narrow constriction somewhere in this area and shooting a jet of air directly at the teeth. And that causes even more intense, turbulent, noisy airflow. So you can hear, if you compare a fricative like s to one like f, you can hear that the s one is much louder. And you can see this quite easily when you look at acoustic representations of speech. These noise components are much louder than other fricatives. So those are referred to as sibilants. Phonologically, the reason this is important is because these sounds with these particular phonetic qualities actually pattern quite differently in the phonology from other kinds of fricatives. So just as an example here of what I mean by patterning differently. So here are a bunch of words that end in fricatives. Cuff, booth, dose, and push. Take a second and remind yourself of which fricatives these are ending with, these four words, and which of them are the sibilants I just mentioned. And now imagine the plural of these four words, cuff, booth, dose, and push. What's the difference between the sibilant and the non-sibilant fricatives here? The answer is that the non-sibilants, th and th, so this is the labiodental and the interdental fricative, these take a plural form that's just an alveolar fricative, sa. So cuff, cuffs, booths. But the sibilant fricatives, like as in the end of dose or push, these take a special plural that inserts a schwa vowel in between the final consonant and the suffix. So it's not, the plural of dose is doses, is. The plural of push is pushes, is. Right? So there's a special vowel that gets inserted there in between two sibilant fricatives, but not in between a non-sibilant fricative and a sibilant. If we want to be able to describe English plurals properly, it looks like we're going to need to distinguish between sibilant and non-sibilant fricatives, and this is what I mean when I say that they pattern differently in the phonology, that there's reasons to distinguish between the two classes of sounds. While English does have a whole bunch of fricatives, there's a lot of other cross-linguistically common fricatives that we don't happen to have in English. So many languages have bilabial fricatives, voiceless hua and voiced va. A lot of languages have velar fricatives, voiceless cha and velar ra. And then many languages also have uvular fricatives, which are fairly similar to the velar ones to the ear of speakers who don't have these distinctions, but they're going to be a little bit further back on this back edge of the velum, the uvula, and that would be voiceless cha and voiced ra. So an example here, the German word for book ends in a voiceless velar fricative, Buch. Interestingly, if you put that voiceless velar fricative from German after an E vowel, you get a different kind of fricative, which is a palatal one. So if you instead try to make a word like this in German with the high front vowel E followed by a velar fricative, this comes out as palatal. In fact, this is the first person, I think, nominative singular pronoun, means I, and like I like first person, and it's pronounced with a palatal fricative, ich, right? Not with a velar one, ich, right? So German has both these sounds, as a palatal fricative, that one's generally written this way, and a velar fricative, but not in this context, that's written with the X symbol. Right? Tashli Berber, I'm not sure why this particular example is here, but it has a voiced uvular fricative in it, Tahausa, which means thing. Okay, so that's fricatives, and then the other major kind of obstruent is a stop. So in a stop consonant, airflow is completely blocked. We call that complete closure, or the closure phase of the consonant. While the airflow is blocked, voicing may continue for a short time, but airflow through the vocal tract does not. And so what happens? Well, just like the voicing thing that we looked at the beginning of the class, you stop airflow somewhere in here, but air is flowing up from your lungs, air pressure is going to build up behind that constriction. Eventually, you release your stop, and the result is a rapid flow of air out from behind that constriction. And that's referred to as a transient in acoustics. What does this correspond to? It's basically the sound of a rapid change in pressure. Right? So pressure goes from really high, because you're maybe blocking off the vocal tract completely by closing your two lips, and then instantaneously you release it, and all that pressure rushes out. So it's a sudden change in pressure, and that tends to be perceived by our ears as a click, pop, or tap. So if you could separate just the release part or the transient part of a stop, you'll find that they sound like this. Something like that. And yeah, so that's what a release sounds like, or a transient. This general fact that when you have a rapid change in pressure, it has this very special kind of auditory feel to us. That's a general fact about human hearing. And in fact, when you do this in speech, there's a rapid change in pressure, but it's not like huge amounts of pressure. Your lungs are only producing, and your diaphragm are only producing so much pressure. It's not enough to hurt anybody. If you up the pressure behind a constriction like this, or the change in pressure, to a very, very, very large change in pressure, it will sound like a boom. In fact, that is what an explosion is. The sound of an explosion is just an extremely rapid and large change in air pressure. Of course, at much smaller amplitudes of pressure, like the ones in your vocal tract, it instead comes out like a pop, a click, or a tap, and that's referred to as the stop burst. I mentioned the explosion thing because you'll sometimes see the term plosive used for these audibly released stops. I tend not to use the term plosive very much in this class, but it's something you'll see out there. And so you'll sometimes even hear the burst or the release or the transient referred to as the plosion of the stop, which is a lot like an explosion. And it's actually the same physical principle underlying these. So unlike a lot of the other consonant sounds that we've looked at in this unit, stops are going to be inherently complex and dynamic, temporally complex. What do I mean by that? Well, basically, if you take a continuant sound like a fricative or a liquid, and you sample it at some time, it's going to sound a particular way, and then you sample it again at a later point in time, it's going to sound roughly the same. So, you know, the beginning of a s sound is more or less the same as the middle of a s sound. The beginning of a l sound is going to be more or less the same as the middle of a l sound. But this is not true at all for stop consonants. Right? So at the beginning, what you're going to have in the acoustic record or in your ears is basically silence if it's voiceless, or a little tiny bit of voicing if it's a voice stop. That's sometimes referred to as a voice bar. Then you're going to have a release, this rapid transient, which only lasts for a split second, like maybe 7 to 20 milliseconds in English, and that can differ depending on a few things. And then after that, there's going to be some short period of frication, and possibly a transition to the next segment, which might involve voicing or not involve voicing. And all of those different phases of a stop turn out to be fairly important to how we hear stops, and also how we produce them. Also, unlike fricatives or liquids or other continuants, or vowels for that matter, at least monophthong vowels, stops are inherently asymmetrical in time. So the beginning of a stop sound during its closure phase is very different from the end of the stop sound following its release phase, because there's really very different articulatory things going on at the two times, and different acoustic or perceptual things as well. I'm mentioning this here now because it's going to turn out to be important later in this class, where we look at the way that stop contrasts work in different languages. So in English, we generally have a series of labial, coronal, and dorsal stops, one voiceless, one voiced at each place of articulation. So there's bilabial p and b, coronal or alveolar t and d, and velar k and g. I put in parentheses here the glottal stop, and this is because it's not exactly contrastive in English, although it's worth sort of knowing what it is and how to identify it. The glottal stop is a sound that appears generally at the beginnings of English phrases when there is a vowel otherwise at the beginning of that phrase, right? So if I give you the citation form or the isolation form for a vowel initial word in English, and these slash brackets indicate the underlying form that a word might have in the lexicon, whereas the square brackets indicate its pronunciation. This word, which underlyingly is vowel initial, is going to come out with an initial glottal stop if it's at the beginning of a sentence, egg. How do I know there's a glottal stop there? I'd need to show you in Prot or in some kind of a software that will show you the acoustics. This is almost impossible for English speakers to hear unless they're trained in phonetics, because it's reliably here. So the main thing I think of as useful here is the example I gave earlier of the English interjection uh-oh, which sounds something like this. It has two glottal stops, uh-oh, and you can compare this to the same thing without glottal stops, which is very hard to do in initial position for English speakers, but not that hard in medial position. So this one that's missing the medial glottal stop would be oh, uh-oh, oh. That difference is a glottal stop. That's what a glottal stop sounds like. Because this is to some extent predictable in English, it basically happens at the beginning of phrases that have vowels in them, at the beginning of vowel initial phrases in English, you get this glottal stop, and it's more or less predictable where it occurs. It's something that English speakers tend not to notice until their attention is called to it. So that's why it's in parentheses there. These pairs in English, for instance, this versus this, these are generally referred to as voicing distinctions, voiceless versus voiced. But in fact, when you look at actual English speech, there's really a tremendous amount of complexity in how they're actually realized phonetically. And I'll briefly summarize this here. I'm not going to go into too much detail. But first of all, the choral stops pattern differently from the velar and the labial ones in that, in between two vowels, where the second vowel is unstressed in English, both the voiceless and the voiced t and d stops become this short tap sound, as in butter, batter, metal. And when I'm saying metal, it's hard to tell whether I'm talking about the one that's written with an underlyingly voiceless stop or the one that is written with an underlyingly voiced stop. In this context, where there's stress here and no stress here, these sound almost exactly the same. There's actually a big debate with experiments and all kinds of data about whether these are exactly the same, but they're definitely pretty darn similar in American English, not in British English, but they're both going to sound like metal, metal. Right? You can tell that these are underlyingly different sounds in the lexicon by adding some things onto the end of these that shift the stress. That unflaps them or untaps them and makes them sound like they're canonical pairs. So, for instance, if you put the ic suffix on this, you get metallic, not medallic, but metallic, showing that this is underlyingly a voiceless stop. If you put a suffix on this one, you can make the word medallion, not metallion, right? Which shows that this is underlyingly a voice stop. But when you put them following a stressed vowel and not before a stressed vowel, they both end up as this extremely short r sound, as in metal, metal. The labial and velar stops in English don't do that. Instead, all of the stops when they're at the beginning of a word or before a stressed syllable tend to actually be aspirated in English. And so aspiration, basically, it's written with this H letter, the same as the glottal fricative ha, and that's what it is phonetically. You have a period of glottal frication after the release of the stop. Right? So in general, in absolute initial position in English, the voiceless stops are going to be aspirated. And the difference between an aspirated and unaspirated stop is something like this. Unaspirated ta, aspirated ta. Da, ta. If you want to know whether a sound is aspirated, one useful thing to do is you can actually detect the glottal frication following that release by holding a piece of paper in front of your face. Da, ta. Does that work? Da, ta. See the paper move for the second one, but not the first? This is most obvious with labial ones because the source is closest to the paper. Ba, pa. Ba, pa. So I don't know if you can see it on the video, but the paper moves with the aspirated one, but not with the unaspirated one. So in English, in general, before a stressed vowel or at the beginning of a phrase, these are going to be aspirated. The voiced ones are, in fact, often not fully voiced at the beginnings of phrases or before stressed vowels in English. They're sometimes partially devoiced. In between two vowels within a word, which is what that VV context in this table stands for, you tend to get more normal voiceless stops and voice stops, except that there's this tap realization for the coronal ones, as in the metal, metal example, and there's also some variation with the voice stops here, which I'll ignore for now. And then finally, at the end of a phrase or end of a word, you tend to get yet another set of different pronunciations of these. And so for the voiceless ones, it can be a normal released, audibly released voiceless stop. It can be partially glottalized. It can be pre-glottalized. You can actually get a fully glottal stop, right? So if I'm looking at an English word that ends in, let's say, a coronal stop, a voiceless one, here's an underlying form for the English word mat, and I can pronounce that as mat, mat with a released final stop. I can do it with a partially glottalized and stop like mat. I can do it with a fully glottal stop, mat. And I can also do it, the last possibility here, right, was just the non-audibly released one. That's indicated with this diacritic, mat. And you'll sometimes see these referred to as unreleased stops. That's not quite right. If you don't release your stop, you'll die. Take a minute and think about why that's true. All it means is that when the stop constriction is released, it's not done in a way that produces a transient, and so you can't hear the stop release. This is very frequent in American English, and you'll get the same sorts of variation broadly with the other voiceless ones as well, and with the voiced ones. So final stops in English are frequently not audibly released. They might be glottalized or partially glottalized or fully glottalized. There's lots of variation. So English stops are super complicated. Other common stop places that you find in other languages besides English would include retroflex consonants, and I've already showed you a couple of these, but example, retroflexion would be the difference between ata, which is non-retroflex, and arta, which is retroflex. Ata, arta. Pretty hard to hear for people who don't have these sounds in their languages, but many languages have retroflex voiceless or voice stops. These would sound something like arta, arda. Palatal stops, cha and ja. These are pretty common cross-linguistically. Uvular stops, which I'm not very good at producing, these would be something like ka and ga. Those are distinctive in many languages, though not in English. Here's an example with a dental versus retroflex distinction in Tamil again. So kadavu, it means door, but kardanda, it means late. Oh, that one's hard. Kardanda, that has both retroflex and dental consonants in it. But that first stop sound in between the two a vowels is going to be dental ada versus retroflex arda. Ada, arda. The final category here within the obstruents is going to be affricates. And these will be sort of marginal. We're not going to spend a huge amount of time on this in the class, but they're sort of like a combination of a stop and a fricative. So just like a stop, you have a closure phase, you completely block off the vocal tract. But then when you release it, instead of just completely releasing the stop, you release it into a fricative constriction. So generally in the IPA, we're going to write these as combinations of stop and fricative characters. And in English, we generally say that there are two affricates, ch and j. And we write these as combinations of a stop consonant, like ta or da, and a fricative consonant, like sh or zh. And the correct way to do this is to use this little slur to join them. Although, this will often be neglected in actual transcription. Why do we think these ones are single segments or single consonants rather than a combination of a stop and a fricative? Well, there are arguments one way or the other, but again, that's going to be a phonological analysis. There's nothing about the phonetics or the sound of these segments that will tell you that they're a single consonant versus two different consonants. We're going to have to wait until we talk about phonological grammar to go through that argument. Right? Other common affricates you find in other languages, well, I should say these are by far the most common affricates in the world's languages. Probably sa would be the second most common, behind the post-alveolar ones. But there are a few others that pop up in some languages. So you can have a labial affricate like pfa, or a velar affricate like k. And so the example I've given here is from German, although I'm told that in modern colloquial German, this distinction is often not maintained, so this might just come out as a fricative. But in hypercorrect or standard or prescriptive German, There's a distinction between the labial stop pa, the labial fricative fa, and the labial affricate fa. So the word for arrow here is something like pfeil. And I'm told that in casual speech or in fast speech that's probably going to come out pfeil, but in hypercorrect German that would be an affricate. So there's an example of a different kind of affricate. I will split off the rest of the handout into one last video.